Network topology. Network topology refers to the arrangement of various elements, links, nodes, devices in a computer network. It describes how devices like computers, servers, switches, and routers are physically or logically connected to each other, and how data flows through these connections. The layout or structure of the network plays a crucial role in determining its performance, efficiency, scalability, and fault tolerance. Understanding network topology is important when designing, implementing, and troubleshooting networks. Physical versus logical topology. Physical topology refers to the actual layout of devices and cables in the network. It shows the tangible connection paths, such as cables running between devices. Logical topology refers to how data moves through the network, regardless of the physical connections. It focuses on the way data flows and the rules governing communication between devices. For example, in a business office, the computers might be arranged in a circular manner physically, but they might use a different logical structure, like a star, for data communication. Types of network topologies. Bus topology. In a bus topology, all devices are connected to a single central cable called the bus. Each device communicates over the bus, and only one device can send data at a time. If more than one device tries to communicate, there can be collisions, leading to data loss or delay. Real-life example: a home Wi-Fi network where multiple devices connect to a single router acts as a simplified bus topology. Advantages: simple setup, requires less cable. Disadvantages: a single point of failure. If the main cable bus breaks, the entire network is affected. Limited scalability. Star topology. In a star topology, all devices are connected to a central hub or switch. The central device acts as a relay, forwarding data between connected devices. This is one of the most common topologies used in modern networks, especially in local area networks, LANs. Real-life example: many office networks use star topology where all computers are connected to a central switch. Advantages: easy to manage and troubleshoot. A failure in one cable doesn't affect the entire network. High performance since data passes through a central device. Disadvantages: if the central hub or switch fails, the entire network goes down. Requires more cabling than bus topology. And a ring topology. In a ring topology, each device is connected to two other devices, forming a closed loop or ring. Data travels in one direction around the ring, passing through each device until it reaches its destination. Some networks use dual rings, allowing data to travel in both directions. Real-life example: some older networks, like token ring networks, used this topology in the past, though it's less common today. Advantages: data collisions are minimized as each device is connected to its neighbors, can handle heavy traffic better than a bus topology. Disadvantages: if one device or connection fails, the entire network can be disrupted. Troubleshooting can be difficult. Mesh topology. A mesh topology has each device connected to multiple other devices. In a full mesh, every device is connected to every other device. In a partial mesh, only some devices are connected to multiple others. Real-life example: telecommunications networks often use a mesh topology to ensure that if one path fails, data can travel through alternative routes. Advantages: high reliability, data can be rerouted if one path fails. Fault tolerance. Disadvantages: expensive and complex to set up, especially in full mesh, requires a lot of cabling and configuration. Tree topology. A tree topology is a hybrid structure that combines elements of bus and star topologies. Devices are arranged in a hierarchy, where smaller star networks are connected to a central bus. This allows for more scalable and flexible network configurations. Real-life example: large corporate networks often use tree topology, where different departments or sections of the organization have their own local star networks connected to a main network backbone. Advantages: scalable and easy to expand, structured and organized. Disadvantages: If the backbone fails, large portions of the network can be affected, more complex to maintain than simpler topologies. Hybrid topology. A hybrid topology is a combination of two or more different topologies. This allows networks to benefit from the advantages of multiple topologies while minimizing their disadvantages. Real-life example: data centers often use hybrid topologies where star, mesh, and tree topologies are combined to optimize performance and reliability. Advantages: flexible and scalable, can be customized to meet specific needs. Disadvantages: more complex to design and manage, can be expensive to implement. Network topology in real life. In modern networks, star topology is one of the most common setups used in businesses and homes because it is simple and efficient. For larger organizations with mission-critical applications, mesh topology is often implemented to ensure high availability and fault tolerance, especially in data centers or cloud networks. Conclusion: understanding network topology is crucial for building efficient, scalable, and reliable networks. Different topologies suit different use cases, and it's important to select the right one based on the network's size, purpose, and performance needs. As businesses grow, hybrid topologies often provide the flexibility needed to expand and adapt to new challenges.